Now that we've described the structure and functionality of StampedLock, we'll walk through some of its key methods. As you recall, there were three modes: writing mode, reading mode, and optimistic reading mode. The writing mode methods acquire the lock exclusively. These methods are pessimistic in that they assume contention can and will occur. All three of the writing mode methods return a stamp value, which is a long that contains a version and a mode encoded into the long. The write lock method acquires a lock exclusively, blocking until it's available. This method can't be interrupted. There's also a write lock interruptible method that can be interrupted. The try write lock method acquires the lock exclusively if and only if it's immediately available. Otherwise, it returns the value 0 to indicate it was not able to acquire the lock immediately. There's also a try write lock that's timed. This acquires the lock exclusively if it's available within the given time frame. Otherwise, it returns 0. This method throws the interrupted exception if it's interrupted. There's also a number of methods that support reading mode methods, which acquire the lock non-exclusively. Once again, these methods are pessimistic in that they assume contention can occur and take steps to guard against that accordingly. All of these methods return a stamp, which again is a long that contains a version and a mode. The read lock method acquires the lock non-exclusively, blocking until it's available. This method can't be interrupted. Not surprisingly, there's also a read lock interruptible method that can be interrupted. The try read lock method acquires a lock non-exclusively if it's immediately available. Otherwise, it returns 0. There's also a timed try read lock method that acquires a lock non-exclusively if it's available within the given time period. Otherwise, it returns 0 if it times out. This method throws interrupted exception if it's interrupted. The third type of methods operate in what's called as optimistic mode. Optimistic reading mode methods acquire the lock non-exclusively. These methods are optimistic. In other words, they assume contention may not occur. The try optimistic read mode returns an observation stamp that can later be validated. However, if the lock is currently held exclusively, the value 0 is returned. Code that uses this mode typically reads the value of the fields and holds them in local variables for use after they're validated. We'll show an example of this use case in the upcoming part of the lesson on the example application. Internally, try optimistic read does a volatile read on a field inside of the stamped lock object itself in order to ensure the fresh values of fields are observed. The validate method returns true if the lock hasn't been acquired exclusively since the stamp was issued. Otherwise, it returns false. Validate is always used after try optimistic read. If validate succeeds, in other words, if it returns true, the synchronization overhead is very low and there's no need to unlock the lock. Let's now talk about conversions. There are three methods that are used to conditionally convert across the lock modes. These calls all work atomically, despite the lack of the documentation illustrating and explaining that in the Java docs. Try to convert to write lock conditionally converts a lock or a stamp to a write lock. If the lock state matches the stamp, then one of the following actions is performed. If the stamp represents holding a write lock, in other words, we're trying to convert a write lock to a write lock, just return it without doing anything else. Conversely, if the stamp represents holding a read lock and a write lock is available, atomically release the read lock and return the write stamp. This represents a lock upgrade. If the stamp represents a read that's optimistic, return a write stamp if it's immediately available. Otherwise, return 0. The try to convert to read lock method conditionally converts a stamp to a read lock. If the lock state matches the stamp, perform one of the following actions. If the stamp represents holding a write lock, then atomically release it and obtain a read lock. This is an example of lock downgrading. Conversely, if the stamp represents holding a read lock, just return it without doing anything else. If the stamp represents holding an optimistic read, return a read stamp only if it's currently available. In other words, if the lock's not being held for reading or writing. Otherwise, return 0, indicating the conversion failed. The third method, try to convert to optimistic read, conditionally converts a stamp to an optimistic read lock. If the lock state matches the stamp, perform one of the following actions. If the stamp represents holding a lock, release it and return an observation stamp. This represents a lock downgrade. If the stamp represents holding an optimistic read, return it if and only if it's validated. Otherwise, return 0 to indicate we couldn't get an optimistic read stamp. The final set of methods are used to unlock a stamped lock. Unlock write releases an exclusive lock if the state matches the given stamp. In other words, if it's a locked lock, it's an exclusive lock. Unlock read releases the non-exclusive lock if the state matches the given stamp. In other words, if it's a read lock. And finally, you can call unlock, which releases the lock state as long as the stamp is valid. Unlock is slightly less efficient than unlock write and unlock read because it has to check what mode it's in. This is the end of the summary of the key methods in the Java StampedLock class.